why mass suddenly needed an explanation. For a long time, mass felt like the simplest fact in the universe, an unquestioned property that objects either had or did not, requiring no deeper story. Stones were heavy. Stars were massive. Particles carried mass the way they carried charge. It was treated as a given, not a mystery. And then physics realized it could no longer explain where mass came from at all. To understand why mass suddenly demanded an explanation, we must return to a period when particles were being cataloged rather than questioned. Electrons had mass. Protons had mass. Neutrons had mass. The numbers were measured, recorded, and accepted. No one asked why those numbers existed. They were treated as inputs, not outcomes. This approach worked until symmetry entered the story. As physicists began unifying forces, they noticed something disturbing. The equations describing fundamental interactions preferred massless particles. Symmetry demanded it. Mass broke the math. Whenever mass was inserted directly, the equations lost their elegance. The universe appeared to dislike mass at its deepest level. This created a crisis. Particles clearly had mass. Experiments confirmed it relentlessly. Yet the most successful theories insisted they should not. Either the equations were wrong, or mass was not fundamental in the way it appeared. The problem sharpened with the weak force. Without mass, its particles would behave differently. With mass added by hand, the theory collapsed. Something had to give. Physics could not simply assign mass arbitrarily anymore. It needed a mechanism. This was a turning point. Mass stopped being a property. It became a question. Not how much mass a particle had, but why it had any at all. What created it? What maintained it? And why some particles had it while others did not. The universe was no longer allowed to be silent on this issue. Mass influenced gravity. It shaped space-time. It determined structure. If mass existed, its origin mattered. Physics could not proceed without understanding it. This realization transformed mass from an assumption into a problem, one that would lead to invisible fields, broken symmetries, and a radical rethinking of what particles actually are. And once mass needed an explanation, the universe was about to reveal that way itself was not what it seemed. Once mass was no longer accepted as a simple given, physics found itself facing a deeply uncomfortable truth, because a property that seemed most obvious in everyday life had no clear origin in equations meant to describe reality at its deepest level. The universe was full of heavy things, yet the mathematics preferred a world where nothing weighed anything at all. Mass existed everywhere in experience, but nowhere in principle. The problem came from symmetry, one of the most powerful ideas in modern physics. Symmetry demanded balance, elegance, and consistency. It allowed forces to be unified. It made predictions precise. But symmetry also imposed strict rules, and one of those rules was brutal. Fundamental particles should be massless. Adding mass directly into the equations was like forcing a wrong note into a perfect chord. The math still worked approximately, but its internal logic collapsed. Predictions lost reliability. Interactions became unstable. The theory no longer protected itself from absurd results. Mass was poisoned to symmetry. This was not an aesthetic complaint. It was practical. Without symmetry, calculations exploded. Probabilities became infinite. Nothing could be predicted safely. The universe itself would be mathematically incoherent. And yet experiments insisted that particles had mass. Reality and theory were locked in conflict. The weak force made this tension unavoidable. Its particles were massive, heavy enough to limit their range. But symmetry demanded they be massless. Physicists tried every workaround imaginable. They adjusted equations. They redefined fields. They patched holes. Every fix introduced new contradictions. The deeper they went, the clearer the message became. Mass could not be an intrinsic property. It could not simply belong to particles. If it did, the universe would not function mathematically. Mass had to come from somewhere else. It had to be acquired. This idea was radical. Particles were no longer defined by what they were, but by how they interacted. Mass was not an identity. It was a relationship. Something particles gained by existing within a deeper structure. This reframing transformed the problem completely. Instead of asking why particles were heavy, Physics began asking what environment could make them heavy, what background could slow them down, what invisible influence could resist their motion and give rise to inertia. The answer would not come from adding more particles in the usual sense. It would come from rethinking emptiness itself, from imagining a field that filled all of space, one that particles could not avoid, one that quietly altered their behavior simply by being there. Mass was no longer a thing. It was an effect, and the universe was preparing to reveal that weight was not carried inside particles, but imposed by the structure they moved through. This is where the conflict reached its peak, because once mass was redefined as an effect rather than a property, physics had to explain what kind of universe could impose that effect everywhere without being seen. The solution could not be localized. It could not be optional. Whatever created mass had to be present at all times, in all places, without exception. Otherwise, particles would change weight as they moved, and reality would fall apart. The idea that emerged was unsettling in its simplicity. Empty space was not empty. It was filled with a field that existed even in perfect vacuum, a field that had a value everywhere, a field that particles could not avoid interacting with. This field did not push or pull in the traditional sense. It resisted motion. It slowed particles down, and that resistance appeared as mass. The particles moving through this field behaved differently depending on how strongly they interacted with it. Some passed through almost unaffected. They remained massless. Others were dragged heavily. They became massive. Weight was no longer a substance. It was friction with the vacuum itself. This mechanism solved the symmetry problem elegantly. The equations could remain symmetric at their core. The field quietly broke that symmetry by choosing a non-zero state. The laws stayed balanced. The universe did not. Symmetry was hidden rather than destroyed. And hidden symmetry preserved mathematical stability. What made this extraordinary was how invisible the solution was. The field did not announce itself. It did not glow. It did not create obvious forces. It simply existed. Particles felt it constantly, yet humans felt nothing at all. Mass emerged silently. This explained why some particles were heavy, while others were not. It explained why mass values were fixed. It explained why the weak force particles were massive, while light remained massless. The universe was not assigning mass randomly. It was enforcing interaction strength. Even more striking was what this implied about matter. Particles were no longer independent entities. They were excitations interacting with a background. Their properties depended on context. Remove the field and mass vanished. Reality itself would change phase. At this point, mass was no longer mysterious in isolation. It was mysterious in totality. Because if a field could exist everywhere, unseen, shaping inertia itself, then emptiness was once again doing something profound. The vacuum was not passive. It was defining what matter could be. Physics had not just explained mass. It had dissolved it. Weight became a symptom. Inertia became emergent. And the universe revealed that one of its most familiar features was the result of an invisible agreement between particles and space itself. The climax of this story is not the discovery of a new particle, but the realization that mass itself is not owned by matter, because once physics understood the mechanism behind weight, the universe revealed that heaviness is something imposed, not intrinsic. Nothing is born massive. Mass is granted, and it is granted everywhere, all at once, by a structure that fills the entire cosmos silently. The field responsible does not act like a force you can feel. It does not pull objects downward or push them outward. Instead, it resists change. It slows acceleration. It makes motion costly. And that resistance is what we experience as inertia. Weight is not carried. It is encountered. This explains why mass behaves the way it does, why it is constant, why it does not flicker, why particles never lose it suddenly. The field is always there, uniform, unavoidable. Every particle is immersed in it at all times. Mass is not switched on. It is sustained. This also reframes emptiness once again. Space is not a void through which matter moves freely. It is an active environment that shapes matter's behavior. Particles are not isolated objects traveling through nothing. They are excitations navigating a structured background. Reality is relational all the way down. What once felt like a fundamental property now feels emergent. Mass is not a building block. It is a consequence, a response to symmetry being hidden rather than destroyed. The universe preserved elegance by disguising it. Order survived by becoming invisible. This realization closes a long loop in physics, from quantized energy to flexible time to probabilistic outcomes, to creation from nothing, to the origin of mass. The pattern repeats. What appears fundamental is often an effect. What feels solid is often relational. What seems simple is often imposed quietly by deeper structure. Mass did not need an explanation because it was strange. It needed an explanation because it was everywhere. And once that explanation emerged, the universe became less intuitive, but far more coherent. Weight is not a mystery anymore, but the fact that it emerges from nothing visible reminds us that reality is not built from objects alone, but from invisible agreements enforced everywhere at once. Sometimes the most familiar features of existence are the ones that hide the deepest truths. Sometimes the universe does its most important work, where nothing appears to be happening at all. Why